Hello everyone, this is the first video of our C++ series, and in this video, the first video, we are going to talk about some tools that you will need when you're coding, like text editor or C++ compiler, something like that. So this video will be based on local environment setup. You can choose the text editor by your preferences, based on your preferences. I mean, you can choose the text editor that you're mostly comfortable with. I usually use Visual Studio Code. It's actually an IDE, but I usually use that as a text editor. There are some other text editors like Notepad++, Genie, Vim, like VSCode that I use. So I can show you that some of them from my browser, I guess. So like Notepad++, you can install it. I was usually using that in my first times, or you can download Sublime Text. It's a good, and also you can I use sometimes Vim. It's based on the terminal. By the way, I usually use Ubuntu. So you can, if you use Windows, you can download a virtual machine for your Windows, or there's a Windows subsystem for Linux. Let me show you that. VSL. It's a configuration that comes with the Windows 10, I guess. So you can check that from your settings by Windows subsystem for Linux. So you can we can compile our source code from the Ubuntu terminal. I mean Linux terminal. So you don't need to use an IDE anymore. So other than that, we have Genie. You can use writing. You can use Genie. It's a good text editor as well. I don't know if it was IDE or not. So that's all. But we're gonna use the VS Code throughout this course. And let me generate a new file. So this is an empty file now. It's a plain text. You can check the type of the text from here. We can type C++ and choose the C++. Then our Visual Studio Code recognizes our code. For example, when I write include IOStream, as you can see, there is a color like orange or purple on the texts. But if it would be a plain text, it wouldn't recognize that. It's a plain text right now. So include IOStream. So as you can see, it doesn't recognize our texts, our statements. Don't save that. So I haven't saved that yet. So after you choose your text editor, the turn comes to C++ compiler. Since I use Linux, I use GNU's Linux C++ compiler, G++ and GCC. Maybe you heard of that. So let me open a new terminal. And you can check if GCC is installed in your environment, like this command, gcc -v. -v means version in here, and you can see GCC version 9.3.0, like that. So it means we have GCC in our environment. So let me clear this. And now let's start with some simple hello world example. we can type. You don't need to focus on these include IOStream right now. I'll explain that to you in a later videos. So the main function, programming is just basically a functions, consists of functions. Int main is you can think main function as a entry point of your program. So basically, what is a function? Let me explain that. Basically, function. So you know from math that fx equals x squared or something like let me multi unknowns, xy equals x plus y, something like that. So you give a function input as x, you can see here, and then the function returns an output for you like x squared, or in here you can give we call it parameters or arguments in programming. So you give x and y as two parameters, and these parameters it gets involved in output like x plus y, and this function returns an output to you or to main program like x plus y. So functions are basically this, but we're gonna explain the functions in another video in a further time. So basically there's an exception for integer main function. Like if you don't say return something, let's say return 0, if you don't do that, let's say std cout hello world and line, std and line, yes, it automatically returns 0, but it's just an exception for a main function. For example, if I define another function like void my function and do something in here but don't return anything, sorry, this must be integer, but don't return anything, it would give me a bug, an error. We get an error. So let's just save this file to not save this file to right now. We can generate like a repository or like let's call it course. We're creating a making a directory for our course. Enter. So if I'm sorry, this must be not here. We should go to desktop. First, I want it to be in the desktop. So create directory, not make this course. Yes. Now with ls commands we can see our directories in here, and here's our course that we have just created with mkdir course. So we can go to into that directory with cd course, and here as you can see we are in the desktop, and in the desktop we are in course directory. So with ls we can see that it's empty, it's an empty folder. So let me clear that. So we're gonna save this file into our course directory, yes, and call it like first lesson and save it. Yes, it's saved right now. So how can we compile our code in Linux, in Ubuntu? We use G++ commands. Maybe some of you familiar with the C, and we compile C as G plus GCC minus C, and something goes like that. And in C++ we call it G++ minus std. It's just a statement for standards, declaring the standards for compilation. We use C++ 11, and to show us all warnings and all errors, and then we type our lesson.cpp. This is our source code. We type our source code and then -o. It makes the whole compilation and linking process. So we type our output file's name. So A. It gave no error and no warning. So we can run this code, this executable file, like this command. So you type // and executable. Whatever your executable name. We called it in here A. So we must write A, and it writes hello world. It prints hello world. So even if I don't state that it must return something 0, it still returns 0, and function terminates in here. When function sees return statement, it breaks the code block. I'm gonna mention a little bit in further time about blocks, and it just breaks out of the program, so it terminates the program. Let's see what happens when we write return 0. Let's just compile it again and run it again, and it just prints hello world again. So after this, let me mention about some basic. What is this statement? For example, it's a statement, and all statements must be ended with a semicolon in C++, unlike some programming languages like Python. Don't need to write something in Python. For example, you can write x equals x plus 1 in Python, but you should write semicolon in C++, and C++ compiler recognizes this semicolon and evaluates this statement after seeing the semicolon here. So basically we call this every statement must end with semicolon. So what is a block? So basically in a function, you can think of a body of the function. So we constrain the blocks with parentheses, and in the parentheses, between the parentheses, you write your statements. So after this, we have something called identifiers. For example, just a little bit before, I typed some statement like this. So what is this X? C++ compiler doesn't recognize this X, and if I try to compile this, it gives an error to me. For example, let's try it. Let me clear this, then compile it again. See, error, X was not declared in the scope. You can think scope as a block, but not the same thing. You can think scope as the same thing like blocks for now, just for now. So we should define our variable, and the definition of this variable, or it mustn't be only a variable. It can be functions or classes or modules or any other types that user defined items. So for example, you can declare int x. Don't just focus on the integer type right now. We will come to variables just a little bit further. So int x, you can initialize this x in here, or you can if you just don't have to initialize it, don't have to. For example, we can set it to 3 and x equals x plus, let me print it out here. Let's print this. And here let us sum x with 5, and after that print the x again and check. And we have commented that we can comment our code out with this. If you wanna comment out just one line, you can use this, but if you wanna just a whole block or huge more than one line of code, you can just type something like this, and every statement that comes after between these two symbols gets commented out, for example, like that. So let them erase right now. So yes, let's compile that and run that. Yes, first our x was 3 and we printed out as 3, and after that we summed the x with 5, then it becomes 8, and after that we printed out the 8, for example x, 3 and 8. So this variable holds the integer that given to it, and after each operation it changes its value. Okay, let's just comment here out, not erase them. So after this we can check the we can talk about include iOS 3. Every statement that starts after the hash, this hash symbol that you see here, is a preprocessor. What is a preprocessor? The first thing your compiler does when it gets to the source code, it processes the preprocessor statements firstly. The first thing that compilers do. So we saw that std cout here. For example, what is the cout? We didn't declare this as an cout or std cout right here. We didn't declare that as an x, but we have an input-output stream library, and it's defined in this cout, or we get a cin, for example, like this. Cout means cout helps us to print something on terminal, and cin helps us to get some input from the user, and it's used like that. For example, let's declare an a and get something from user, and cout that's a, for example. Yes, let's do it like that as well. So let's check this out. Just comment them out. The X part. Okay, so let's compile it. Oh, we got an error. Alright, as you can see, the error has occurred. Alright, stdc in a. Alright, so basically I just got an error because of that. We have compiled it and run it, and see, it never prints out something because it waits from us to give it an input for a integer a. So we type 4 and press enter, and it prints 4. Why it prints 4? Because after we gave an input a, it prints out with C out and A to the terminal. So let's delete all of them. I was explaining the include IO stream. So basically our STD, some basic reserved identifiers. For example, you can call your identifier as an identifier let's call it reserved identifiers for C++. Let's delete that. For example, it's not recommended that you call your variables like something like else or auto or something like if or const, because these identifiers are almost every one of them reserved by C++. So you can call your function int else because it gives an error to you. So you must call your function something like, for example, I'm just giving an example, int my function and something like that. See, it's not reserved by a C++. You can check it by the color. And other than the reserved identifiers for C++, so these reserved identifiers such as else, auto that I mentioned just a minute ago are defined in the IO stream file. So we are including it can be used in other languages like import, as you can see, maybe you see in Python. So we include this library IO stream in our file, in our source file. So it's just copy pasting the library's source code in our file. You can think just like that. So our program doesn't give us the error like why you didn't define else or why you didn't define auto, like that. But if you define our own identifiers like integer, I don't know, it's just a variable, by the way. Integer is just a number. So integer a, we have defined this. So after this point, we can use whatever we want in our program, in integer main program, integer main function. So that was the identifiers, and by the way, just these reserved keywords, like reserved identifiers like auto, else, if, or const, called keywords in C++. So we can talk about, it's just a topic of another video, but we can talk about some variables, we have variable types like boolean, integer, or char, or float, or short, or long, and it goes like that, and we have long. The variables are important because you need to define or declare that, say to the compiler that I am going to allocate memory in this size. For example, boolean gets 1 byte size. It means 8-bit size. And when you define something bool, let me write that down here, bool check, we declare that, and our allocation has done in memory, we either in stack or heap, we're gonna discuss about that later. So check is allocating 1 byte memory. Let me, that's okay. And boolean is just consists of true and false values. True, false. An integer is the integer, as you know in English, and it gets the 4 bytes allocation in memory. Char is basically characters char, abbreviation for a character, and it gets 1 byte allocation. Float gets 4 bytes allocation in memory. And short gets 2 bytes. Long gets 4 bytes. Long gets 8 bytes allocation in the memory. So we usually use integer and float and double and char, not short, long, or long in our programs, but there must be a need for them in some type of programs. So let me explain the integer. For example, we call it 4 bytes allocation, and it just can take interval. It just can take numbers. For example, bytes, 1 byte equals 8 bits. Therefore, integer can and signed integer can start from minus 2 to the power, we say 4 bytes, minus 2 to the power. For example, if we say 4 bytes, it means we set it 1 byte, 8 bits, so 32 bits. It starts from 2 to the power of 31 bytes to 2 to the power of 31 minus 1, because it's guessed the 0 in the middle of the interval. So it's assigned. We span our 1 bits for sign of the integer. But if we can declare it as a signed, unsigned it, for example, unsigned int x, and if we define it like that, unsigned ints can take values that such an interval that starts from 0 to 2 to the power of 32. So because it's 2 to the power of 32, because we didn't spend our 1 bit to for a signed integer. It always positive. And same thing applies for the float, short, long, and long, long. For example, you can say on unsigned long. I couldn't write that. Unsigned long, long. Something A, for example. Something like that. And something that I mentioned about char is you should check the ASCII table from the internet. Maybe we can check it in a moment. So when we define char, let's say ch equals a, we assign ch a to the ch. So if you wanna print out the ch, oops, yes, std and fine. Let's do this, compile that. Oh, it's we get the error as warning. So we declared and bool check and unsigned int x, unsigned long, but didn't use that, so that's not a problem. Just comment them out. And yes, let's clear this, compile it and run it. It prints A. So it's just we're designing ch and assigning the A to the ch as a letter, but only user, the programmer, I mean myself and you themselves, know it as an ch, I mean character. So it's just basically turning to a number in binary. So this A is just basically a number, and character still holds the number, but we see as A, and it gets turned to a letter and gets printed to the terminal after all the steps. So you can check the ASCII from here, ASCII table. So every one of them has a decimal correspondence. For example, we typed in letter A. A corresponds to a 65 in decimal. So machine code sees as 65. It's not a letter. It's actually a 65, just a number. But for the sake of the simplicity of the program, we get it as a letter. So it was the intro to variables, and I think that's all for this video, and we are going to continue explaining variables a little bit more and do some examples about them, and also getting into functions as well. So that's all for this video. Thanks for watching. Goodbye. Take care.